Okay, hi, Assalamualaikum. My name is Nurul Hirani Afida, which is from Group C, and which is Muhammad Alif Irwan bin Rusnan, Nur Natasha binti Abdul Ghaffar, Selina Damon anak James, and Muhammad Taufik bin Amir.
Hi, my name is Lina Domana James and my committee number is 262. So today our group, which is Group C, will be presents about the sustainability in the pavement engineering. And first is we had the chapter 1, which is the introductions to the sustainability. So the definitions of the sustainability in the context of pavement engineering, which is this concept of sustainability, have been implemented by a variety of the institutions, corporations, agencies, organizations, and governing bodies. And the main objective of the sustainability is to design, construct, and maintain the pavement with focus on the goal of minimize the long-term impact to the environmental, social, and economic factors. And also the aim is to construct and manage the transportation infrastructure, which is can fulfill the current demand without endangering the capacity of future generations to meet their own needs. Next. So next is the importance of sustainable pavement design, which is first is the resources conservation. So sustainable pavement design seeks to minimize the consumption of the natural resources, such as like the aggregate and also petroleum-based binder. And then energy efficiency, which is when we use the traditional pavement design, we can it can be energy intensive, but with the sustainable pavement design, we can optimize the use of the resources such as like the material, energy, and water, which also can reduce the energy consumptions and help to mitigate the impact of pavement on climate change and also reduce the reliance on fossil fuels. And next is longevity and durability, which is sustainable pavement design have a longer lifespan and also require less frequent maintenance of road. Then with this also we can recycle and also reuse back the materials that can have a negative environmental impact, which is impact in the water pollution, air pollution. So by recycling and reuse the material, it can help to reduce the demand for new resources. And that's the climate resilience, which is involve the design of pavement that can withstand the extreme weather conditions. For example, the temperature fluctuations, heavy rainfalls, and also other environmental issues. Next is social considerations. So the sustainable pavement take action in social factor like accessibility, safety, and the effect on the community. This entails to creating the pavement that can minimize the noise pollutions, improve pedestrian safety, and also it can consider the needs of surrounding neighborhood. And then the last one is life cycle assessment. So assessing the life cycle of pavement material can help engineer to able to make decisions to minimize the negative impact on the environmental and also maximize the sustainability. So next we're going to explain about the chapter 2, which is the material selection. So the next is the type of the sustainable pavement materials, which is first one mixed asphalt. One mixed asphalt is produced at the lower temperatures, which is it can reduce the energy consumption during the manufacturing process. And then we had the recycled concrete aggregate, which is produced by crushing and reprocessed the all concrete structure, and it contributes to reduce the landfill waste and also conservation of the natural resources. The next one is porous asphalt, which is porous asphalt can allow water to pass through the pavement surface, stormwater runoff, and also the groundwater recharge. And then permeable interlocking concrete paver, which is it consists of the open joint, which is allowing the water to infiltrate through the pavement surface. It can help to reduce the stormwater runoff, flooding, and improve the water quality. And next is the rubberized asphalt. And these materials can obtain by recycle the tire rubber, which is it can hang the pavement performance by improving the flexibility and reduce the road noise. Next is the fly ash. which is this product is from the coal combustions that can be used as the supplementary cementitious material in the concrete mix. It can enhance the strength and also durability of the concrete. And then the geosynthetic. It used to reinforce and also stabilize the pavement, which help to reduce the thickness of the pavement layer and can improve the load bearing capacity. And the last one is the glass hull, which is it's a make of recycled glass cullet and then is turned into the asphalt. So the criteria of fly ash material, which is the material that we use for the pavement sustainable pavement design. So this material is a byproduct from the burning pulverized coal in the electric power generating plants. It burning and float out from the combustion chamber with the exhaust gases. So the use of the fly ash in the pavement concrete can improve the pavement performance, especially in the rigid pavement. It can reduce the thermal power industry, disposal and storage costs, and also it helps to reduce the cement consumed and also related carbon dioxide emissions. And other than that, it helps to place the concrete at a lower slump value without altering the required walkability. It also results in denser concrete with greater ultimate strength and durability. And then it minimizes the number of air gaps in the concrete and it's making it denser and more impermeable. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Alif Irwan Milusnan. Today I'm gonna explain about the design considerations and life cycle assessment about the topic of sustainable pavement designs and material selection, which is the material is fly ash. First of all, I will explain about the design consideration that consists of 5 considerations that we need to take care of before we choose fly ash as a pavement material. Okay. The first consideration is fly ash and replacement ratio, which is we need to choose between class F and class C. Class F is, for example, polozonic, which is for long-term strength, and class C is cementitious, which is for early strength. Typical replacement range is 15 to 30%, but adjustment are possible. These considerations underscore the versatility of fly ash in sustainable pavement engineering, offering flexibility in meeting both performance goals and environmental objectives. The next consideration is mixed design optimizations, which is the main point is mastering the mix for stronger and more workable pavements. We need to highlight the importance of mixed design optimizations to overcome the water demands and workability challenge while reaping the benefit of fly ash. And the third one is strength and durability, which is build stronger, longer lasting pavements that receive wear and tear. In this point, we need to focus on the improvement of strength, durability, and reduce the maintenance of the pavements. The fourth consideration, which is the environmental considerations, which is building stronger pavement with greener footprints. In these considerations, it is important in order to reduce the CO2, to divert waste, and to increase the durability. Next, the last one is economic considerations, which is pave the way for long-term saving with stronger and lower maintenance pavements, which is we need to emphasize durability and cost benefits in order to use fly ash as a material in a pavement construction. Okay, moving into the next point, which is life cycle assessments, also known as LCA. First of all, what is LCA? LCA is a life cycle assessment, which is a tool to evaluate the environmental burdens of a product or system throughout its entire life cycle, from resource extractions to disposals. This is the phase or the flow of the LCA, which is the first one is raw material extractions and processing. The second one is transportations, moving into productions, next constructions, and use phase, and lastly end of life. Okay, this is the short explanation for each flow, which is the first one is fly ash, which is fly ash is already a waste product, so minimal environmental impact compared to mining virgin material such as limestone for Portland cements. The second phase is transportations, which is can be lighter than Portland cements, which is leading to lower emissions but distant from source metals. Use local fly ash when possible. The third phase is productions, which is less energy intensive than cement productions, lowering carbon footprints. Specific mix design and production methods also influence the impacts. The fourth phase is constructions, which is generally a smaller impact than the other stage, but using energy efficient equipments and practice help minimize it. Next phase is productions, which is potential for reduced maintenance and extended pavement life can significantly lower environmental impact over time. And lastly, which is the sixth phase is end of life, which is recycling potential further reduce environmental footprints compared to the traditional pavement disposal. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Taufik bin Ahmed. My metric number is CF200130. Now I want to present about the economic viability. The long life concrete pavement is defined as the following. First, pavement with a shelf life of at least 40 years. Next, pavement that will not habit premature construction and materials related distress. 3. Pavement that has a reduced potential for cracking, faulting and spalling. And 4. Pavement that maintains desirable ride and surface texture characteristic with minimal intervention and only minor repairs. Project Wool Life Cost analysis is used to compare economic efficiency of different investment options. First, develop design options. Second, life cycle maintenance plan. Third, life cycle cost. Fourth, discounting net present value. And lastly, open selection. Comparing cost using fly ash and traditional. Fly ash is less expensive than cement, which is used more frequently in traditional pavements. Fly ash frequently less than cement, which lower the cost of the material. Fly ash can lower maintenance and repair expenses while improving the long-term performance of pavement. Traditional pavement may require more regular maintenance and repairs, raising overall life cycle costs depending on the local circumstance and grade of materials utilized. Thank you.
Okay, hi, Assalamualaikum. My name is Nurul Herani Afida binti Muhammad Arifin, and I will share about some inspiring case study showcasing its benefits. So, first is Green Pavement in Florida, a 2018 study by the University of Florida compare conventional concrete pavement with those containing fly ash. So, the outcome were impressive. Is first is reduce CO2 emission by 12 to 15%. So, substitute cement with fly ash lowers the carbon footprint of pavement construction. So we can enhance durability and crack resistance. Fly ash pozzolanic properties improve long-term strength and minimize permeability. So the last is lower heat of hydration. This is translate to reduce thermal cracking, especially crucial in hot climates like Florida. So next is cost-effective roads in India. 2017 project focused on implementing fly ash in concrete pavement for rural roads in India, and the result were clear: a significant cost saving of up to 50%, and the lower cost of fly ash compared in cement makes it a budget-friendly alternative. And we can improve pavement performance, and fly ash pavement demonstrate higher compressive strength and better resistance to wear and tear, and reduce environment footprint. Fly ash utilization reduce the need for landfill disposal and promote resource conservation. So, the third is all-weather performance in Washington State. The Washington State Department of Transportation conduct a study in 2012. So, the comparing fly ash concrete and conventional concrete in bridge decks, and the finding were remarkable: increased resistance to do salts and freeze the cycle, and this is a critical for pavement in cold climates like Washington. So, second is he can improve workability, which is the fly ash concrete mix is easier to place and finish, streamlining construction, and he can reduce pavement shrinkage, and which is this minimize the risk of cracking and ensure long-term structural integrity. So the last is the last of a case study, which is urban green space integration in Germany. In 2020, Hamburg, Germany implement permeable pavement contain fly ash in a public park, and this pavement offers several benefits, which is you can reduce stormwater runoff, and they mimic natural soil drainage, minimize urban flooding, and protect water quality. And next is urban heat island mitigation, which is he can permeable pavement allow rainwater infiltration, lowering air temperature, and creating a cooler environment. Next, last, which is enhanced aesthetic and green space integration. So, this innovative design contribute to a more attractive and sustainable urban landscape. Thank you.
Assalamualaikum and hi, my name is Natasha binti Abdul Ghaffar and I will explain about the barriers and opportunities. For the barriers, the first one is technical concerns, lack of awareness and knowledge, which many engineers and contractors are unfamiliar with the properties and benefits of fly ash in pavement applications. Next is standardizations and mixed design challenges, which the existing pavement design standards and mixed design considerations may not adequately account to the variability of fly ash properties. Next is leaching and environmental concerns, which leaching of heavy metals from fly ash into the environment, although the researchers suggest for proper treatments. Next, the second one is economic considerations. Fly ash is upfront cost, which is the cost of transportation, handling, and specialized equipment for the incorporating it into pavement is higher. And next is lack of economic incentive, which the economic benefits not well established and sufficiently attractive to incentivize widespread adoptions. And the third one is social and regulation barriers, which is the public perceptions and concern, and the public concern about the potential health and environmental impact of fly ash often based on misconceptions, and also the regulatory hurdles, which stringent regulations regarding fly ash handling and disposal can add complexity and cost to the project. The last one is lack of qualified workforce, which is a shortage of skilled workers trained in handling and incorporating fly ash in pavement. The next one is for opportunities. The first one is policy incentive. The financial rewards make them cheaper than traditional materials in context of subsidies and tax breaks, and also the market muscles. The government becomes a bigger buyer, requiring and preferring fly ash into public projects. The second one is research and development. The standardized clear rules for mixing fly ash make it reliable for builders. The next one is treats and improve. The research of fly ash make it safer and stronger for better roads and smarter transport, which is new ways to move fly ash cheaply and easily. And the third one is public awareness campaigns. Tap into environmental concerns, show how fly ash routes are eco-friendly, and fight climate changes. And also bath mist, clear communication addresses health concerns and build trust. And next is showcase success stories for the real projects, prove that fly ash works and is strong. And next one is get creative, engaging social media exhibits and community events make it relatable. And the last one is turn skeptics into advocates, empower people to support a greener future paved with fly ash. Okay, for the future trends, the technological advancement. The first one is smart pavement. Smart pavement embedded with intelligence, sensor and healing capabilities, which is sensor monitoring traffic, cracks, and the environmental for predictive maintenance. Next is 3D printing. This technology offers precise placement of fly ash based off mixture, and it is achieve both customized design and reduce waste. Next one is advanced nanomaterial. The pavement fortified with nanomaterials translate to longer lifespan and also reduce maintenance. The second one is evolving environmental regulations. Thrives under stricter environmental regulations. Next is incentive for using fly ash due to the lower carbon content. Next is aligned with circular economy principles. And regulation mandate recycled materials like fly ash, reducing the landfill waste, and also life cycle assessment policy favor fly ash for its lower environmental impact. And for the innovation incentive, it is like from the government and institution for field research. The third one is additional trends. Hybrid materials combine fly ash with recycled plastics or glass fibers, and then tailored to specific needs of environmental conditions, and then prefabricated fly ash pavement blocks for speedy constructions, and also the streamlines the entire pavement construction process, and drives policy changes and boosts market demand for sustainable innovative incentive from government and also institution for research. And the last one is emerging applications. Specialize the mixed design and dust mitigation strategies address health concern, and then tailored fly ash mixture for unique environmental challenges such as flooding and permafrost, and then creates resilience pavement suitable for extreme environment. And also the last one is integrating the of renewable energy source like solar panels or piezoelectric materials. That's all from me.